A lot of trig today. All right, sine of 5 pi over 3. Okay, here's how I'm thinking when I see sine of 5 pi over 3. Sine's the y-coordinate. So if I can know the y-coordinate at 5 pi over 3, that'll be my answer. 5 pi over 3, that's fourth quadrant. Over 3 is the steep angle in the fourth quadrant. And then the y-coordinate is the long side there. And long sides are always root 3 over 2. So negative root 3 over 2. That's how I think through the unit circle. I know people teach it differently and memorize it differently. That's how I remember it. Tangent of 4 pi over 3. Well, the tangent 3 trick is that if a 3 is in the bottom, the answer is root 3. Right? And if a 6 is in the bottom, the answer is root 3 over 3, because there's two 3's. I'm looking for like number 8. There's that one's going to be root 3 over 3, because there's two 3's to make a 6. I need to back up here because I need to think about positive or negative. What quadrant is 4 pi over 3 in? Third. And what's the sign of tangent in the third? Positive. Either all students take calculus, or tangent is sine over cosine. They're both negative, therefore the tangent is positive. Cosine 3 pi over 4. Cosine's the x-coordinate. Over 4 is the middle angle. 3 over 4 would be in the second quadrant. And the x side, well, that's that middle length side. All of those are root 2 over 2. But it's going backwards, so negative root 2 over 2. Cosecant. Who's cosecant paired with? Sine, so I need a flip of sine. Pi over 6. The sine of that's 1/2. And so if I flip it, I get 2. All right, why don't you try the rest of those as a pre-cal reminder, and as a further reminder, or you can get zeros, you can get undefined. When you flip a 0, you get undefined, so that will happen occasionally. And also, you don't have to flip square roots that are in the bottom. So if you flip it and the square root goes to the bottom, you can leave it there since you're in calculus now. All right, so you try the rest, and that looks like a whole bunch of popsicle sticks I'll pull in a minute. And if we're going down, it's got to be negative. Ryan, how about the tangent of 11 pi over 6?
Negative square root of 3.
Over 3? If there's a 6 in the bottom, there's two 3's in the answer. That's the tangent 3 trick. It takes two 3's to make a 6. That's just a memorization technique. All right, next 4. Cody, how about the cosine of 5 pi over 6? Yep. Leah, the cosecant of 4 pi over 3?
Negative 2 square root 3 over 3.
Yes. Remember that if you just flipped it to negative 2 over root 3, that would be okay as well. Like, we don't have to fix them in calculus. If you're in the habit of fixing them, it's fine, but you don't have to. Maddie, the cotangent of 2 pi over 3? Negative 1 over square root of 3? Yes. Yes? Yes, that's right. And Selah, the secant of 7 pi over 4? Wait, 2 radical 2? The cosine is root 2 over 2. And if you flip that, you get 2 over root 2, which is equal to root 2. But again, you don't have to fix these, so you could leave it as 2 over root 2. All right. Trevor, Barrett, Sophia, and Braden for the next 4. 13, Trevor, sine of 7 pi over 6? Negative 1/2. Barrett, tangent of 5 pi over 4? 1. Sophia, cosine of 2 pi over 3? Negative 1/2. And Braden, the cosecant of 5 pi over 3?
So that's what quadrant's that?
It's almost 2 pi, so it's in the fourth quadrant.
So it's negative 2 over root 3, right?
Yes, yes it is. All right, Claire, Graham, Audrey, and Zach. I'll put you on the spot, Zach, after I know you were struggling with these. Pausing to give these people a chance to check as they're checking with their neighbors frantically. Claire, the cotangent of 7 pi over 6? Root 3. Graham, the secant of 11 pi over 6? 2 over root 3. Because we flipped the cosine. Audrey, how about the sine of 3 pi over 2? Good. Sometimes people get messed up with the ones that land on the axis markers. Fancy word is those are called quadrantals. But if it lands there, it's 0 or 1, or in this case, negative 1. Zach, the tangent of 3 pi over 2? Undefined. Did you know why that one was? Okay. Tangent is sine over cosine. And at 3 pi over 2, let's see, that coordinate would be 0, negative 1. So that's negative 1 over 0, because cosine's the x-coordinate, sine's the y-coordinate. And if you got 0 in the bottom, it doesn't work. Undefined. Last four, Tristan, Ryder, Hector, Laura. Tristan, cosine of pi, negative 1, so that's just over on the left. Ryder, the cosecant of 0.
0.
Who is cosecant, like reciprocal partners with? Sine. And what's the sine of 0?
The sine of 0 is 0, right?
Right. So if I flip 0 over,
Fine.
undefined. Hector, the cotangent of pi over 2
0.
is 0. And Laura, the secant of pi over 2? Undefined. Because the cosine is 0 and we flip it over, we put 0 in the bottom. Okay. A worthwhile 20, 30 minutes there, 20 minutes anyway, of reviewing unit circle stuff. Hopefully it came back. It looked like it eventually came back for most of you. A few of you need to spend a few minutes with your unit circle again. Right? Did you have to do the unit circle date last year where you submit a picture? No? Or yes? Take it to Sonic or whatever? Okay, so we're going to skip the bottom part of this page because the bottom part of the page is like plugging things into a calculator and you sort of figuring out what the derivatives are. But we don't have time to do that. Let's just jump to the answers. All right, so anything over 0 is what? Undefined. That's right. If 0 is in the bottom, it doesn't work. Just making sure I heard that right. Derivatives of trig functions. You got to memorize these. So this is 6 new pieces of information, although it's related, so it's not like 6 random pieces of information. But these are things, this is what you would start to put on note cards. If you're starting to build a collection of derivatives, you'd put these on note cards and then review until you can't miss them. The derivative of sine is cosine. And again, this is just straight, you got to know this. There's not a long explanation of why that is, or at least if there is, it's longer than we want to worry about. Derivative of sine is cosine. Derivative of tangent is secant squared. That's kind of weird. That one you actually can derive, but it's too long to worry about. Derivative of secant is secant tangent. Secant of x, tangent of x. Okay. If you memorize those, you can figure out the others. Because the derivative of cosine is negative sine of x. So you flip the sign and sort of flip the sine cosine, the co or not co, basically. So following that pattern, anyone want to guess what the derivative of cotangent is? Negative cosecant squared. Change the sign and flip the co or not co. So what do we think the derivative of cosecant is? Yep, negative cosecant cotangent. So yes, it's 6 things you have to know, but I'm going to box the first 3 because you can sort of figure out how to get to the second 3. Laura.
And also, I was just watching a YouTube video, and they said that if there's a c in front of all the ones on the right, cosine, cotangent, cosecant, they all start with a negative, like the answer. So if it starts with a c, there's a negative in front.
Never noticed that before. I like it. The non-C's are positive, the C's are negative. If you make a C, that's a negative situation. Okay, so let's try some of these. And these are pretty straightforward because we don't really know much else right now. So we don't know how to combine things yet. That comes later. Number 1, if y equals 2 sine of x, then dy dx is, what do we think? It's the derivative of sine. Cosine. That's kind of all it is for that one. Number 2, g of x is 17 tangent of x. Then g prime, 17 just kind of goes along for the ride. And I want the derivative of tangent. So right now you don't have it memorized. Right now you're looking at the table, and that's fine. The derivative of tangent is secant squared. Why don't you try 3 and 4? 4 just shoves a bunch of things into 1. So again, it's not hard. Eventually you're going to have to know these 6 trig functions. Right now you're just looking back, and again, that's okay for now, but eventually you're going to need to memorize those. Number 5, oh, fancy words, instantaneous rate of change. What does that mean? Derivative. Oh, at a particular point. So derivative of cosine's negative sine. Derivative of tangent is secant squared. So this will take a little bit of work. Negative sine pi over 3 minus secant squared pi over 3. Sine of pi over 3. Steep angle, first quadrant, root 3 over 2. Let's see, pi over 3. Secant goes with cosine. Cosine would be a half. Flip it, I get 2. Square it, I get 4. Oops, let's label what we've done here. That's f prime of pi over 3. I have really good news for you. Well, 2 pieces of good news. This doesn't happen a lot on the free response section, but if it does, here's the really good news. This is considered a safe stop. Because it's calculator ready and it's not calculus. So on a free response question, you don't really have to know the unit circles. It pains me to say that, but you don't have to know the unit circle. You can leave it as sine of pi over 3. Now, most of the time, these simple ones are going to be a multiple choice, and they're going to give you the final answer, the simplified answer. So, most of the time, you'll have to know it. But, on a free response, it's okay to leave it without knowing, without evaluating things. All right, the rest of these are just more practice of the same thing. Take a derivative, plug things in. So you need to do these just because it's good practice. So we're up to worksheet number 4, I think. Let's grab worksheet 4, and with a few minutes left, we'll actually do switch to the stuff that's due. Actually, these are going to go quick. So I would probably keep your notes handy because you don't have these memorized yet. I get that. So start on the worksheet. Rare we have time to work. Rare still that we have enough time to work. But these are going to go pretty quick. So start some on worksheet 4 and maybe knock out a bunch.